Alrighty, we are finishing up our study of exponential growth and decay here. The first start thinking part is looking at three different tables and trying to figure out if it's exponential, linear, or neither for growth or decay. So the way that you can figure out if it is linear is if you are going to have a constant rate of change. Usually that is looking like you are adding or subtracting the same number over and over and over. And then exponential is going to look like you are multiplying or dividing by the same number over and over and over. And if it's not one of those, then it is going to be neither. So when we look at this first one, it's kind of first hard to tell whether this is being multiplied by the same number over and over and over. So what I did was I did 12 divided by 10, and that gave me 1.2. And if this was the case, then I'd be multiplying by 1.2 over and over and over. And that was the case. So I knew that was exponential. Now, technically, you could have like 1.2, 1.2, and then 2.4 if the other side, there was a change of x instead of a change of 1 each time. If it went to a change of 2, then it would reduce back over to that 1.2 common ratio. So that one is going to be exponential. The second one, when you check to see if you are adding, subtracting, multiplying, or dividing by the same number over and over and over, you are not. And that would be the case because if you look at x, it goes 0 straight to 1, straight to 2, straight to 3. It does not skip any numbers, so it's not like it would look funky at all. The next one, I look at the x first just to see if those are consecutive numbers, 0, 1, 2, and 3. They are, so that we can look at the other side and just see if you are adding, subtracting, multiplying, or dividing by the same number over and over and over to get the next number. And in this case, we are adding 4 each time. So this is going to be linear. And the reason would be there is a common difference. Now, once again, if it went 0, 1, 2, 4, then you would have plus 4, plus 4, plus 8. But when you look at the ratio of the change of y over change of x, it would always give you the same thing of 4 over 1 when you reduced. Okay, the main thing that we're doing in this lesson right here is we are looking at graphs and trying to make sense out of them, making sure you guys know what the original amount is, how to find the rate of change, and all that. So the first one says, which phone is more expensive to buy when it is first released? So that would be your vertical intercept. So you could see phone A had a vertical intercept of 1,000, whereas the other one was 840. So that tells you that the phone A was going to be more expensive at $1,000. The next one says, how does the value of each phone change with every passing year? So what you can do is you can take the value for the second point and divide by the first one. So if I take the second one on phone A, 600 divided by 1,000 is 0.6, which is 60%. Now you got to be very careful. That is either 60% decay or that's saying you have 60% left. And when we look at this, it can't be 60% decay because that would mean it would be worth less than half of what it was before. So it must mean that you have 60% left, which means you dropped by 40%. The next one, when you do 630 divided by 840, you end up getting 0.75, which either means 75% left or it went down by 75%. And since we can see this did not drop significantly, then it must not be that it was 75% decay. It's actually 75% left, which means that there is going to be a 25% drop per year. So that's how you can figure out what the decay is going to be. The next one says, which one is falling in value more quickly? Well, according to that, phone A is definitely dropping quicker. It's at 40% versus 25%. The next one says, how much is it going to be worth in 4 years? Now, me personally, I did E first, because once you have that equation, it's going to make it way easier to figure out how much it's worth after 4 years. So I came up with the equation, which we know is just going to be original amount times 1 minus r to the x, or in this case, to the t. So the first one is 1,000 times 0.6 to the t, which means there is 60% left after every year. And the next one is 840 times 0.75 to the t, meaning there's 75% left after every year. And when you substitute in a 4, you can see the two different values. It's $129.60 versus $265.78. So oddly, the one that started more expensive, since it was dropping quicker, ended up being worth less after 4 years. You'll actually see this a lot of times. For example, if you look at a Range Rover car, those are very expensive, but they depreciate very, very quickly and become worth not that much after a certain amount of time. Whereas like something that costs less, like a 4Runner, holds its value really, really well. So after 10 years, a lot of times a 4Runner which was like half the price of the Range Rover, is actually going to be worth more than the Range Rover is at that point. Now, the last thing that we did here is we had these different situations, and you were supposed to match the situations with the graph. The main idea here is that we want you to be able to look for certain characteristics that will let you use process of elimination. For example, if you know something's supposed to be growing, then you can knock out the ones that are decaying. Supposed to be decaying, you can knock out the ones that are growing. Then you go to the next easiest thing to check. Check the original amount, see if that tells you anything. Or you can then look at like rates of change. So the first one says that a stock is going to double every 4 years. So that obviously is growing, which means it can't be graph A or graph D. It's got to be C or B. Then it tells you that it doubles every 4 years. You can just look at 4 years and see if it had doubled from 4 years before that, and you could see that was graph B. The next one says that it triples, which means it is growing, and by process of elimination, we know that's going to be C. The next two are both decaying, but one is decaying at a rate of 1/4 per year, and the other one is 2/5 per year. So when you look at this, it is either going to be A or D, and you can take your values. Let's say you get the 1500 and you take away a quarter of it, which is saying that you still have 75% of it. And when you do that, you can see that that would be graph A, and the next one would be graph D. Now let's go ahead and move on to the homework. On this first problem here, it says the two graphs show models characterized by exponential decay representing the area covered by two different algae blooms in square yards W weeks after different chemicals were applied. And it's asking the first one, which algae bloom covered a larger area when the chemicals were applied, meaning which one starts out higher. And you can see that that would be the one that was represented by triangles. So the one indicated by triangles, because of the vertical intercept, which is normally called the y-intercept, is going to be higher. It is going to be 500 versus 200. Which algae population is decreasing more rapidly? So I kind of winged these locations. You can't figure out the exact amounts, but it isn't close enough to the point where it's going to matter if you're off by a little bit. So one of them dropped by 40 over, and the previous one was 200, and the other one dropped by 160, and the previous was 500. So one of them dropped by about 20%, and one dropped by 32%. Either way, you can see that it is the one that is modeled using the triangle, and it's going to be dropping faster at a rate of 32% versus the 20%. Now on number 2, it says a medicine is applied to a burn on a patient's arm. The area of the burn is in square centimeters, and it's decreasing exponentially and is shown in the graph. It says, what is the fraction of the burn remaining each week? So you could take the next term and divide by the previous. So at time equals 1 week, it's 6, and previously it was at 8. So we could do 6 divided by 8, and that says that there's 75% remaining after the first week. Write an equation to represent this. Well, we know the original. You can see your vertical intercept is at 8. So you could say 8 times 0.75 to the x, meaning it decreased by 25%. Make sure you know 0.75 does not mean decreasing by 75%. It's how much is left. The next one is what is the area of the burn after 7 weeks? We can just substitute in the 7 into our x, and you end up getting 1.068 square centimeters. And it looks like that, if you followed your graph, that is reasonable. It does look like it would get down to about there. On number 3, it says the graph shows the amount of medicine in 2 patients after receiving injections. The circles show the medicine in patient A, and the triangles show in patient B. And what we were supposed to do is try to, they gave us the equation for patient A, it's 300 times 1/2 to the h, and they want to know which one of these is possible for patient B. Patient B is going to be the triangles. Well, the first and most easiest thing to look at is just the vertical intercept, which is the original. And you can see the triangle one is lower than the circle. So if we already have the circle being 300, we can knock out anything that had an original of over that. So A and B are out. And then we have to look. Letter C says that you only have 3/10 left, which means a lot of it went away. And the other one says you have 7/10 left, which means it's decaying by 30%. And that one looks more reasonable. It looks like the triangles have dropped by about 30%, not by 70%. Okay, on these other ones, you were supposed to write out your equations that modeled the situation. So the current savings rate, I just looked this up, for Ally Online Bank is 3.85% per year. If you deposit $6,000, how much will this be worth the next years? And just for your knowledge, it's probably not going to stay at 3.85, but for the problem, we're going to pretend like it does. So you do the original, which is 6,000 times 1 plus the rate, which is 0.0385, all to the x. Be very careful. Every year I have kids say 1 plus and then 3.85. They forget to change it to be a decimal. And if you did that, you would find out that it would just made the number get way too big, way too quick, and it wouldn't make any sense, because that would actually mean like a 400 or 385% growth or something, which would be insane. The next one says the number of acres of grass is decreasing exponentially due to grasshopper infestation. There were originally 30 acres of grass, but it's decreasing at a rate of 12% per year. How many acres will they be in X weeks? So when you're looking at this, it is going to be original, which is 30 times 1 minus the 12%, which is 0.12 to the x. The next one is the population of mice triples each year. So when you do a problem like this, you don't use that equation because it's a little confusing. You would just say, how do I triple something? And it's just multiplying by 3, and you're going to do that a certain number of times. So you would have your 6 mice times 3 a certain number of times. And the way we say times 3 a certain number of times is 3 to the x. Now, 2 more problems. This is Darren is trying to write an equation for the following situation, identify all mistakes. So the population of termites is increasing at 6% each day. How many termites will there be in 2 weeks if there is originally a population of 100? So it looks like the original is fine at 100, but you can see that instead of putting 0.06 for the rate, he just put a 6. That's a problem. That's not correct. It's supposed to be 1 plus 0.06. And then the next thing is 2 weeks. It's also, they told us 2 weeks, and then it is going to be up by 6% each day. So 2 weeks is actually going to be 14 days. So you're supposed to substitute in a 14. And then is simply trying to find the mistake that Elsa made here. So it says the car is valued at $19,000 and depreciates at a rate of 18% per year. What is the value in 7 years? So you can see that the original was put in correctly. They put the 7 in the correct place, but they thought that 18% decrease was 0.18, when really you're supposed to do the 1 minus the 0.18, leaving you with 0.82. Now, I did not write this down because I thought it was implied, but it is just going to be y equals 19,000 times 0.82 to the 7th. Or you could write 1 minus 0.18. Hopefully that made sense. Thanks for watching.